At this point of the lesson, I hope that you're trying these on your own because we've encountered a lot of different kinds that are basically covering all the different types that you need to cover. There might be a few exceptions as we go. Start by reducing if you can. This does not reduce. Don't try to reduce the 6 and the 2. Please don't. No, you'll get hurt. It's not worth it. Don't do it. Don't be a hero. So that one doesn't reduce, actually, because nothing reduces, and that's the whole point of finding a whole. So find any factors that cancel. Nothing cancels, right? The point where you can see it. So there are none here. No wholes. X-intercept is where y equals 0. So instead of writing 0, I'm just going to write a y. Let's fix that. Whoa, let's fix it again. 0 equals... Okay, now I did say also 0 equals, just numerator, 0 equals 6. No, it doesn't. So there is no x-intercept. Okay, y-intercept, you can cover up your x's. 6 over negative 2. If you want to do it the other way, you could say 6 over 0 minus 2. It's going to give you negative 3. So we will put a dot at negative 3 on the y-axis. Vertical asymptote is where the denominator equals 0 after you've reduced it, but there is no reducing to do. So x equals 2. That's it. Horizontal asymptote. Okay, using the same shortcut that has not been fully articulated on paper yet. Let's just stammer our way through it. How about that? What's the degree of the denominator? Well, it's linear, so it's 1. I didn't give you any wait time on that. What's the degree of the numerator? It's 0. I want it to be the same. I want them to have the same degree, so let's just make them the same. But you can't just do that. You can't be like, oh yeah, I'll give you an x. No, you had 0 x's. I can't do that. I mean, I can't just give you an x, right? You had 0, so I'm going to put 0. Well, what that really means is, divide your lead coefficients. 0 divided by 1 is 0, which again makes sense. I had no x-intercept, so I won't cross the x-axis, so y equals 0. All right, that means we are not going to touch the, well, x-axis, which I just said. There's your red line. Don't cross it. Okay, I'm sure there are other coordinates we could get to be a little more accurate in this, but the general shape is going to be here. And then up here, and again, I'm not going to be too picky about where the coordinates actually are, but do go through the coordinates that you do have, coordinate in this case, or the hole. You'll at least not cross through the hole, but you'll look like you're about to. See? Oh, almost did. But you also need to follow along the general guideline of the asymptotes. There you go. Okay, how many discontinuities do we have on this one? Major course correction. There we go. Just that one. There were no holes. So there are no removable discontinuities. We do have a non-removable discontinuity, and it occurs at the vertical asymptote. And again, no holes, so we would go, oh, major course correction, but no blip. That would be a removable if it was just blip.